Welcome to another exciting lesson in Mathematics 10. For today's video, we are going to discuss the end behavior of graphs of polynomial functions. The learning objectives are: the learner should be able to, number 1, describe the end behavior of the graph. Number 2, apply the concept learned in interpreting the graph of polynomial functions. Number 3, show accuracy in performing one's task. Now let's recall what is the degree of a polynomial function. When we say degree of the polynomial functions, this refers to the highest power of x in its function. What about the leading coefficient of a polynomial function? The leading coefficient of a polynomial function is the coefficient of the leading term. Now let's apply this concept in identifying the degree and leading coefficient of the following polynomial functions, and we have to do it mentally. Number 1, f of x is equal to x raised to 3 plus 2x raised to 2 minus 4x plus 1. The degree is 3. The leading coefficient is 1. Number 2, f of x is equal to x minus 4 plus x raised to 2 minus 6x raised to 4. The degree is 4. Leading coefficient, negative 6. Number 3, f of x is equal to 5x raised to 4 minus 3 plus x raised to 2. The degree is 4. Leading coefficient is 5. Number 4, f of x is equal to x times the quantity x raised to 2 minus 3. The degree is 3. Leading coefficient, 1. And number 5, f of x is equal to the quantity negative 2x raised to 2 minus 2 times the quantity x raised to 2 minus 2. The degree is 4. Leading coefficient, negative 2. For today's discussion, we are going to do a certain traveling. Iloilo City, known as the City of Love, is a home of different tourist attractions. Can you name these attractions? Also note every mathematical graphs or figures that can be described for each Iloilo City tourist attraction. Number 1, Molo Mansion. Number 2, the Archdiocesan Shrine of Santo Niño de Arevalo. Number 3, this is the Iloilo River Esplanade. Next, this is Plazuela de Iloilo. Next, Waterworld Iloilo. Now, after that, we are going now to discuss the end behavior of the graph of polynomial functions. What is the end behavior of a graph of a polynomial function? The end behavior of a graph of a polynomial function is the behavior of the graph of f of x as x approaches positive infinity or to the right, or negative infinity or to the left. The degree and the leading coefficient of a polynomial function determine the end behavior of the graph. That is why we had that review earlier. The leading coefficient is significant compared to the other coefficients in the function for the very large or very small numbers. So the sign of the leading coefficient is sufficient to predict the end behavior of the polynomial function. So we are going to do a leading coefficient test in order to determine the end behavior of the graph of the polynomial function. For that, we have here 4 cases. Case 1 is when the degree is odd and the sign of the leading coefficient is positive, the end behavior of the graph is falling to the left and rising to the right. The example of this is f of x is equal to x raised to 3. So as you can see here, the graph rises to the right and falls to the left. So we have here the real-life examples of odd positive polynomial functions. So if you can recall, this is from the water world. So the graph or the slide rises to the right and falls to the left. And also, our and the other is from the Iloilo City National High School gate. Case number 2 is if the degree of the polynomial is odd and the sign of the leading coefficient is negative, the end behavior of the graph rises to the left and falls to the right. So in this example, we have your f of x is equal to negative x raised to 3. As you can see, our graph here rises to the left and falls to the right. And we have here real-life examples of the graph of an odd negative polynomial functions. Case 3 is the degree of the polynomial function is even and the sign of the leading coefficient is positive, then the end behavior of the graph both rises to the left and to the right. Example, f of x is equal to x raised to 2. So both the end behavior of the graph rises to left and right. So we have here the real-life examples of the graph of an even positive polynomial function. Next, if the degree of the polynomial function is even and the sign of the leading coefficient is negative, then the end behavior of the graph both falls to left and right. Example of this is f of x is equal to negative x raised to 2. And as you can observe, the parabola is opening downward. And here are the real-life examples of the graph of an even negative polynomial function. Now let's have some illustrative examples to discuss what we have learned earlier. Illustrative example 1. What is the end behavior of the graph of f of x is equal to negative x raised to 5 plus 1? Now, to know the end behavior of the graph of this polynomial function, let us identify whether the degree is odd or even, and whether the leading coefficient is positive or negative. So, the degree is 5 or odd, and the leading coefficient is negative. Therefore, the graph rises in the left and falls to the right. And this is what the graph of f of x is equal to negative x raised to 5 plus 1 looks like. Illustrative example number 2. What is the end behavior of the graph of f of x is equal to negative 0.0875 x raised to 4 plus 0.075 x raised to 3 plus 0.745 x raised to 2 minus 0.357x plus 2.3. Solution: the degree of the polynomial function is even and the leading coefficient is negative. Therefore, the graph both falls in the left and in the right. And as you can see, the graph of this polynomial function is that of the logo of McDonald's. And let's have first a short trivia. Don't you know that there are names for the different shapes of nuggets in McDonald's? The names are bone, bell, ball, and boot. Illustrative example 3. The graph is represented by f of x is equal to the quantity 0.08x minus 1 times the quantity 0.08x plus 1. Identify the end behavior. Solution. Since the polynomial function is in factored form, we need to add the degree of each factor. So the degree here is equal to 1 plus 1, which is equal to 2. And multiply the leading coefficient of each factor to find the leading coefficient. The quantity 0.08 times 0.08 is equal to 0.64. Since the degree is even and the leading coefficient is positive, therefore the graph both rises to the left and right. And this is the graph of the curve of a banana. And let's have another trivia. Banana is one of the common fruits that Filipinos love. The scientific name for banana is Musa sapientium, which means fruit of the wise men. Bananas are high in potassium and pectin, which is a form of fiber that helps in digestion. Let's have the last example. Identify the degree leading coefficient and the equation of the polynomial function of the graph below. Solution. So the graph rises to the right and falls to the left. Therefore, the degree is odd and the leading coefficient is positive. To find the equation of the polynomial function, we need to identify the zeros of the polynomial function, or where the polynomial function crosses the x-axis. The zeros are -1, 1, and 2. And we have to express it as products of the factors. So we have here the answer. F of x is equal to the quantity x plus 1 times the quantity x minus 1 times the quantity x minus 2. That's all for today's video. I hope you have learned something about the end behavior of the graph of polynomial functions and where we can see it in different tourist attractions in Iloilo City. That's all for today. Thank you!